Good afternoon. I'm Trevor Mead, a staff associate with the Green Parking Council. I would like to welcome you all to our webinar on parking lighting efficiency. This presentation is part of our continuing series of informational webinars to educate the parking community on various issues related to the implementation of sustainable technologies and programs in parking facilities across North America. If you encounter any technical problems during the presentation, please email Gretchen Brown at gretchen@greenparkingcouncil.org. By adopting energy-efficient lighting, the parking industry can tremendously reduce their energy consumption while lowering operating costs. In fact, the potential for energy savings in the lighting of U.S. parking garages exceeds $1 billion annually. This webinar will address the challenges and opportunities that parking facility owners and operators face as they look to implement more energy-efficient lighting technologies in their lots and garages. In addition, we will introduce a program being developed by the DOE in partnership with GPC, the IFMA, and BOMA to promote the adoption of these technologies. In a few moments, GPC Executive Director Paul Wessel will reflect upon a national event he attended last week in Denver, which focused on the development of this program. Our second presenter, Michael Meyer, from the DOE's Pacific Northwest National Laboratory, will explain the specifications that the DOE has created for parking lot and garage lighting. Gary Cudney, president of Carl Walker, Inc., will then give us perspective on the challenges and opportunities that parking facility owners and operators face as they look to implement energy-efficient lighting technologies. Each presenter will speak for 10 minutes. Please enter any questions you may have into the chat box located on the left-hand side of your screen. We have allotted 15 minutes at the end of the webinar to answer questions. The webinar will run no longer than an hour. Paul, can you now share about your experience last week?
Sure. Thank you very much. So I just attended an extraordinary meeting of the Commercial Building Energy Alliance at an extraordinary location, the National Renewable Energy Lab in Golden, Colorado. This is a rendering of their net zero garage. All sides of the garage are open to the elements to allow natural ventilation throughout and preclude the need for a mechanical system. The membrane of fabric panels augments the openness to help control daylight, wind, light glare. It was very impressive. So my work at the meeting focused on launching a collaborative campaign to increase energy efficiency and cost savings in parking, garage, and lot lighting. More on that in a bit, but first some background on the CBEA. You see here a list of some of its members. Sorry it's small. The ones highlighted in yellow we spoke with directly about the campaign, and they're all on board. It's a great start from the building owners community. Some background on the CBEA. CBEA members control more than 8 billion square feet and represent approximately 20% of the total U.S. floor space in their respective sectors. And those sectors include retail, commercial real estate, hospital, and higher education. Those are each subgroups for the CBEA. And the overall goal of the CBEA is to collaborate to reduce energy use. The Alliance seeks to transform the way commercial buildings use energy. CBEA invites building owners, managers, and operators to work with Department of Energy staff, like Mike Meyer, who's joining us today, and with each other to identify and implement best practices, key decision-making tools, and advanced technologies for significant energy savings in their portfolios. On the second day of the meeting, lighting manufacturers were invited to participate. These were some of the companies present. For obvious reasons, they too were excited about this campaign. Among a number of the participants, there was a clear feeling that the future of lighting is solid state, of which LEDs are the most common. Solid state lighting technology has the potential to reduce U.S. lighting energy usage by nearly a half and contributes significantly to our nation's climate change solutions. The U.S. Department of Energy's role in all this is to act as a catalyst to drive R&D breakthroughs in efficiency and performance, and they really seek to equip us as buyers to successfully apply these technological innovations. And the question in my mind coming out of this meeting, and one which we shall explore throughout this campaign, is when will that future be here, and what stands in the way of our getting there? DOE and its labs are able to provide extraordinary technical resources, a point which was increasingly driven home by the major building owners at the meeting. They clearly valued the support that DOE was able to offer this project. Clearly, everybody recognized the challenges, the market challenges for LED lighting, initial cost, time necessary for payback, questions about quality and the like. And everybody understood that understanding this is part of what we need to be doing collaboratively. So a little bit about the collaboration. The collaboration leading this campaign is us, the Green Parking Council, the Building Owners and Managers Association, and the International Facility Management Association. It's a very strong group, and we were grateful to be asked to join the team. It's an especially good collaboration since the major work of the Commercial Building Energy Alliance to date has been with the likes of Walmart, Kohl's, and Target, huge centralized organizations which operate very differently from the commercial parking market, which most of us are engaged in, with its mix of operators, managers, owners, and tenants, and with an overlay of 3 to 5 year contracts. So the goals of this campaign, and we're still forming it, and we're going to want to hear people's input both during and after this call, this webinar, is we want to take the work that's been done to date and take it downstream into these more complicated markets. So we want to focus on things like being able to increase the number of parking structures and lots, taking advantage of energy efficient lighting, accelerate the uptake of these new technologies, document best practices and some of our failures and the energy savings, recognize through this campaign exceptional performers and innovators, help hone the business case around what makes this viable, in fact it is viable, and test the specifications that have been developed, which Mike is going to talk about a little bit, and finally to inspire evangelists. If our thinking is right about the opportunity here, we really want to identify people in the marketplace who are excited about it and help them spread the word. The kinds of questions we're at this point trying to answer are, what are the obstacles to adoption of these new technologies? How do we overcome them? How do the specifications that have been developed work in the marketplace that many of us inhabit? What inhibits the market? How do we create these evangelists? What role can lighting vendors and installers and electricians play in this whole process? And how do we continue to build this collaboration with IFMA, BOMA, and the other organizations that are involved? So we invite you to work with us in figuring this out. We'll be fleshing out the details over the summer and launching the campaign in late August. We're trying to figure out a sexy, exciting approach to this project, including coming up with a better name, which is what you see in front of you now. The working name has been the High Efficiency Energy Lighting Campaign. The acronym for that is HEAL, which we didn't particularly like. We sort of stumbled across this idea of us being luminaries or luministas, and maybe we can do something with that, but clearly there's a lot of room for creativity here. So we really welcome everybody's input who's on the call. Trevor?
Thank you, Paul. I would now like to introduce Michael Meyer from the DOE's Pacific Northwest National Laboratory. Mr. Meyer is a lighting engineer experienced in architectural lighting design with knowledge specializing in sustainable lighting design, controls, and new technologies. He received an MS in lighting from Rensselaer Polytechnical Institute and has been lighting certified by the National Council on Qualifications for Lighting Professionals. Michael?
Thank you, Trevor. So I helped develop a couple of the specifications with the Commercial Building Energy Alliance members. So their input led the way to certain decisions. So through the questions, you might say, well, what about this technology and this technology? And sometimes they're included and sometimes they're not included. And that's because the CBA members definitely had certain opinions about either what technologies they were either familiar with or technologies they've been tried and they were unsure about. And we'll continue on. The first specification that developed...
Michael,
yes.
Could you just speak up a little bit?
Not a problem. I can't always tell how loud I am. The first specification that was developed was a parking lot specification. It does only, the CBA members only want to focus on LED lighting, and so that's the way it is written around. And it does focus on the parking lot. The way it saves energy is it sets a power density. Most people might be familiar with this as watts per square foot. And it sets a power density that is lower than current commercial codes and some state codes, and there's a comparison in a little bit. It also sets some minimum illuminance. So rather than just saying use less power, the Commercial Building Energy Alliance members said, well, actually, we want to also get good lighting out of it. So it's a performance specification. It says how much light you need for how much power can you use, and power is a stand-in for energy because controls could definitely mitigate some of your energy use. Because of the time when it was developed, the warranty was a very big deal. It's somewhat of a big deal now. I say that somewhat because most LED manufacturers have gotten on board with different warranties now than they're traditionally with. When we first started out, warranties were very short, and now they've gone to 3 to 5 years, 5 years being more common. And then there's also some life extrapolation, since the end of life of LEDs is much different than other technologies. I'm going to just step quickly through some different elements of the specification rather than going through the whole thing. The specification can be found via a link from the the Green Parking Council website. As I said, that it is a performance-based specification, so it focuses on amount of light. And parking lots are focused on minimum light levels, not average. We often talk in averages, but at the end, they all only focus on minimums. Parking lots also have now moved from a single value to now what's called a lighting zone value. So depending on whether or not you're located in, let's say, rural western Massachusetts versus downtown Boston, you need less light in the rural areas than do in the urban areas. And so the specification incorporates these different lighting zones. A lot of codes and a lot of requirements have also moved into this manner. As the number increases, you need more light. And so these are some of the sample values. Again, these are minimum values. You can always exceed them. Some retailers do choose to exceed them, but these were minimum values. They do exceed some of the values currently recommended by the IES RP20, which is the parking facility document, but again, this was driven by the CBA members. The specification also treats the parking lot as the slide advances threw me off there. The parking lot treats the parking lot as 3 different sections rather than just saying one part of the parking lot needs or the whole parking lot needs the same value. Perimeter parking, you don't need as much light versus what we call front aisle, where the pedestrians are actually crossing from the parking area directly into the building. This is your greatest chance for conflict between a vehicle and a pedestrian, so it gets the most amount of light. And then rear areas and loading docks, they don't need as much light because there's less pedestrian traffic, there's less vehicles back there, and they tend to be more frequented by people such as delivery drivers or other people who know the parking lot very well. The parking specification also, as I said, breaks down those different zones. So you'll notice, as I just said, that the front aisle, which is the center column, always gets more minimum light than the other ones. That's, again, because where there's the greatest conflict for people and vehicles to interact in an accident, you need the most amount of light, so they're the most visible. So those are some of the specification values. As I also said, the specification uses power density as a stand-in for energy, and I always say that because power density just really looks at how much watts you're using. It doesn't say how you're using them. So if you were turning these lights off at midnight, you're actually saving more energy, but there's some time calculations that have to be factored in, and so it's a little harder to do those type of calculations. So in the current methodology that we're using that most people are familiar with, again, is watts per square foot or lighting power density. On the left-hand side, you'll see the different zones. Again, lighting zones 2, 3, and 4. The higher the number, the more light you're going to need, and therefore the more watts per square foot you're allowed under the specification. And the highest is 0.08 watts per square foot. The other 3 columns in this table show a comparison. So if you were using this specification to meet your lighting needs, you would be roughly 50% better than standard 90.1 2007 at zone 4, 0.8 versus 0.15. If you're using standard 90.1 2010, you would still be better but not as good. And then California Title 24 2008 values are shown there as well. The Title 24 is in the process of being updated, and we'll update those values the next time. There's been some installations of using the specification, and those are usually what people are always interested in. And what do I get if I use it? What are the paybacks? What are the savings? The first site to use it was Walmart. They've actually incorporated it in a number of their sites. The exact number is hard to actually remember because it changes quite often. They have, I believe, about 80 sites completed and something about another 100 or more in design in various stages. But this site was 500,000 square feet, 500,000 of parking. That's a fair amount of area. Originally, it was used 92 LED luminaires. They actually came back and have, since this was rolled out, they've actually been able to pull back a couple more fixtures, and it makes it even more competitive. It's 37 feet. People always want to say, well, how much, do I have to lower the poles? Do I have to do more? In this case, they did have to use more poles than they normally would have, but the mounting height was the same. They're getting a minimum foot candles of 0.8. But they still do talk in averages, so we provide that value. They're seeing a payback between 6 and 10 years. Their payback number, as I said, changed recently because they were able to do this with a more efficient design. The reason why it's a range is that Walmart has proprietary pricing, and so we were unable to really get the full sense of what they're paying, and we estimated it. Also, there's some labor in there, and we, again, didn't know what they were paying there. In Leavenworth, electricity is really cheap, 6 cents a kilowatt hour, and still yet they had a really good payback. And they're seeing roughly a 60% energy savings compared to their standard design, and they're coming in at 0.04 watts per square foot. It's a pretty big win for Walmart overall. But it's not just Walmart who's looking into it. The next site that demonstrated it was a strip mall in Manchester, New Hampshire, where TJ Maxx was an anchor. It's has a bunch of other stores, a Cold Stone Creamery, and other type of stores like that. It's a much smaller site. It's about 150,000 square feet. They use 25 fixtures from Beta LED. A mounting height is 33 feet. So again, the traditional metrics that we're used to looking at, number of feet, area lighted, mounting height, they're very similar. This was an actual replacement of an existing system. They just took the head down and installed this, and were able just to put up the new fixture. Here they wanted a little more light, so they're at about a minimum of 1 foot candle and an average of about 2 foot candles. So it's very uniform. The payback here also ranges. That's because they had some electrical issues separate from the lighting, and they corrected those during the reinstallation, and so it affected the payback numbers. The cost of electricity here was much higher at 14 cents a kilowatt hour, but they're also seeing about a 63% energy savings compared to their previous installation. And they're also at 0.04 watts per square foot. Interesting to note, they're also using occupancy sensors at this site. So after about 9 or 10 o'clock, depending on the time of the year and when the stores are closed, obviously in the winter when the stores are open later, it's much later. But the lights go from a high setting to a low setting. And they're seeing even more savings by using the occupancy sensors rather than lighting an empty parking lot to the full output the whole night. The last site is another type of shopping area. This one's in Falls Church, Virginia. It has a Safeway as an anchor. It abuts a Target site. Again, it's about 130,000 square feet. This layout is very different compared to the previous one. That's why there's 55 fixtures. It's kind of a very chopped up parking lot, and so the lighting required more poles just because, and more fixtures because of the way all the there's a small standalone restaurant in the middle of the parking lot and some other elements that requiring more fixtures. But again, normal mounting height of 30 feet. They had an average of about 3 foot candles and a minimum of 0.9 foot candles. The payback here was either 3.5 years or 6.5 years. They originally had a 1,000 watt metal halide and realized they were just overlighting it, and they considered going to either the LED system or pulse start metal halide. So we compared them against each other. So still both good paybacks at a reasonable electricity rate, and depending on what metric you're using, seeing about 40 to 75% energy savings. Each of these 3 sites have been very happy with the lighting they've installed. The parking lot specification was well received, and people said, well, hey, I have parking structures. I'd like a parking structure specification. So we developed that following. And this is not LED specific. It's fluorescent, induction, or LED. It does a similar thing where it sets a power density and sets a minimum illuminance. The reason why it works with those 3 sources is that those sources can be used with lighting controls, and where you can really save more energy through the use of lighting controls because many parking structures are empty in the middle of the night, and yet they're lighted to full output. Parking structures are available to also, you can there's a tax incentive, which is known as 179D. There's 2 links there for it, and they can also help with the cost effectiveness of it. The specification, as I said, sets a minimum power density, which is 0.18 watts per square foot, which is 40% lower, so it meets the maximum EPACT tax incentive. And just so some people may not be familiar with this, EPACT specifically allows for the coverage of parking structures through this interim rule. We don't often think of parking structures as interior spaces, but technically they are. As I said, there are 3 different technology sources. Sorry, the delay's throwing my rhythm off. Fluorescent, LED, and induction. And in terms of light levels, we currently are looking forward towards the new version of RP20, which is going to increase the amount of light levels as proposed for parking structures, and we anticipate it going from 1-foot candle minimum to 2-foot candle minimum. So that's what these current values are, slightly higher than RP20 as of now. If that changes, we will revise it accordingly. As I said, one of the advantages of parking structures, or one of the things to think about a parking structure, is that since they're operating 24 hours a day or more than 18 hours a day usually, they're a great advantage for controls. The upper left picture is a parking structure in California that is getting ample daylight, and yet the fixtures are operating at full output. The one on the right is a parking structure in Rockville, Maryland, where they're using both a daylight hold and an occupancy sensor. So the fixtures along the perimeter are completely off during the daytime, and the ones on the interior turn on and off with the occupancy sensors, and seeing great savings potential. The final 2 slides I want to show are always why occupancy sensors make so much sense for a parking structure. Is that the slide is a So at the Department of Labor in Washington, D.C., they have a subterranean parking structure where they retrofitted 100-watt HPS parking structure luminaires with LED bi-level luminaires. What you're seeing here is a Thursday in January. You can see the standard pattern that in the middle of the night it's at its low setting, which is just below 1/10 of an amp, and then people start coming in and out between about 6 a.m. and 9 a.m. There's a lot of activity until the lights are at full output. Then there's a morning lull where people are at their desk, lunch, afternoon busyness, and then about 7 o'clock they start leaving, and from 8 o'clock on they're pretty much in their low state. Then you compare that to a Sunday when they're essentially nobody coming in because it's an office building, and it's operating in its low state almost the entire time. And so the savings potential is much greater with an occupancy sensor in this type of scenario where because the occupancy is not entirely known, but so the occupancy sensors can put it into low levels when they're not being used. At this time, I'll return the presentation to Trevor.
Thank you, Michael. I'll now hand the presentation over to Gary Cudney, PE, President of Carl Walker, Inc. Mr. Cudney specializes in parking studies and operational consulting, parking structure design, and restoration. During his 28 years in parking consulting, Gary has developed wide-ranging expertise in parking planning, sustainable and green parking design, functional design, lighting, security, revenue control systems, and structural engineering. Gary?
Thank you, Trevor, and thank you to the GPC for having us involved in your webinar. Also, just thank the GPC for their Garage Demonstrator Site program. Carl Walker is part of our founding sponsorship of the GPC, has a couple green garage demonstrator sites. Fifth Avenue Garage in Ann Arbor, Michigan, which is the big hole in the ground when this picture was taken in on the left. It's now about to open in a few weeks. And then the Colorado State University parking structure on the lower right. Well, parking lighting used to be easy. It wasn't very many years ago, probably 3 to 5 years ago, where the standard parking garage lighting was high-intensity discharge, either the high-pressure sodium shown on the left, which is the yellowish amber-colored light that was usually picked because of its energy efficiency, and the lamp life and maintenance costs were lower than the picture on the right, the metal halide fixtures. but we all kind of like the metal halide better, even though it costs more because of the white light. And this was a before and after picture of the same parking structure that we were involved in the swapping out of gold high-pressure sodium to metal halide. And that's an exterior shot. This slide shows an interior slot. When we did the lighting upgrade, we also stained the ceilings white. You can see what a difference it makes between the HPS on the left and then the nicely relit and painted garage on the right. And those were not altered pictures. That's really the remarkable difference that occurred. Today, the high-intensity discharge fixtures, the HPS and metal halide, aren't really being used much anymore in parking structures. The trend is fortunately what the DOE's specs included, the fluorescent new technology induction or LED fixtures, and we'll talk a little bit more about those. Some of the trends that we see is a lot more interest in LED and induction, but a lot more pulling the trigger for fluorescent fixtures, it seems, because of their lower first cost and we guess simplicity, amongst other reasons that we'll get into. Whatever direction you go, we see many of our clients, and we recommend this as well, that you install demonstration fixtures. The fixture suppliers will provide you 2 to 4 of their fixtures in most cases, and you can install them side by side in an existing parking structure and see how they work, see how they look, check out the glare and the lighting quality. And that's something we really recommend to do an in-the-field observation of the next bullet, which is doing a lighting analysis. And as the DOE specs recommend, doing a initial lumens analysis of the lighting conditions, and then also look at the depreciated value of the lighting. We're also advocates of the control technology that the DOE spec is promoting, where you can turn on and off fixtures or lamps or dim fixtures based on the time of day, photocell for ambient light levels, and motion detectors. And all these technologies work well with those control systems. Now this shows the IES, and until Mike had just mentioned, I didn't understand why they had used 2-foot candles for a minimum. The top box shows a 1-foot candle for the 1998 version of the RP20, which is going to be updated hopefully this year. And our company, Carl Walker's company standard, was 2-foot candle minimum, so it's good to see the industry following our company standard. I also like to check kind of the old National Parking Association standard of 5-foot candles average with a 4-to-1 average to minimum ratio as a good check on the quality of the uniformity of the lighting. We believe to get this kind of good lighting uniformity that 2 fixtures per bay, the picture on the lower right, gives much better lighting at admittedly a little bit higher cost, but better lighting than a single row of fixtures down the center of the drive aisle. The DOE campaign, as Mike had mentioned, they have a parking structure sample spec as well as a parking lot performance spec. The parking structure one, we were pleased to see the use of all 3 of the newer technologies. Their fact sheet on this provides a very good comparison to the different technologies in a matrix form. The specs will give you very efficient lighting, but substantial energy savings, 40% or more without control. And if you put motion detectors and photocell control, the projects where we've done that, we've seen 60 to 70% reduction in the electric bill. So some of the benefits you're going to have from this: improved lighting, we believe, with improved perception and security, which hopefully can lead to less crime. The enhanced perception will, from a marketing standpoint, help draw customers to your parking facilities and create more parking revenue. Savings at the pump, so to speak, of 40 to 60 to 70% reduced energy, and less maintenance as well, because all of these technologies have much longer lamp life than the old HID. For instance, the metal halide, if the lights burn 24/7, if you're lucky, they would last about 1.7 years, where fluorescent is the least of these at 4.1, so almost 3 or 2.5 times as much. There's certainly other financial incentives other than the lower electric bill. It's, if you take into account the the tax credits and deductions and utility company rebates, the EPA Act. The payback period in many cases is less than 2 years, and many of the manufacturers will even finance the. It costs something obviously for the financing or leasing of the new lights, but you can do this for no upfront cost. And that kind of answers one of the biggest obstacles is the cost to implement. Well, if you can make money today, why wait until your cash flow improves and pay a little bit more today, still come out ahead, we believe. So there's some technological concerns. The LED, primarily the concerns there were around quality of the offshore suppliers, and when they first came out a few years back, they were talking about 100,000 hour life, and now then it was 80 and then 70, and now we're talking 50 to 60,000 hours, which seems more reasonable until they can prove themselves. The fixtures themselves, the early ones, had some real problems with glare and poor lighting uniformity, and every day it seems they're coming out with new fixtures that are improving, but still have a little ways to go to really provide the best quality lighting distribution with the lower cost, because the LED does have the highest first cost of these options. Induction has lower lumen output, so you may need more fixtures than for the other technologies, and when the induction lamp burns out, some of the fixtures you have to replace the entire fixture, and there's quality issues. We've got to make sure you get good quality lamps as well. Fluorescent, there's this perception that it's old technology, but with the new T5 and T8 and the electric high efficiency ballast and the vapor tight enclosed housings, that's really not old technology. It is very much new technology. We've got mercury in the lamps, which is a bit of a disposal issue, but you can handle that through proper recycling of those lamps. There's still about a 20% depreciation of fluorescent lighting output in cold weather, but you can take that into account in the design, and a little bit more maintenance because the bulbs burn out faster. The control technology, the biggest obstacle we hear anyways is that, man, we have a hard time keeping our staff and having them trained, and the software is probably just going to be too complex for us to deal with to manage the control system. And then there's concern if you start turning fixtures off or dimming them, well, for certain, Murphy's Law is that's when some incident's going to occur, and there's going to be security and liability issues, and kind of afraid to pull that trigger. And many of our clients, they may pull the trigger on fluorescent, but they're still waiting for the better LED fixture to come out, dealing with some of its issues. So that's primary obstacles. We like to do a comparison where we look at life cycle cost and payback comparison of the different technologies. This little table is an example, but there's lots of variables that go into this sort of analysis, and it really is case-by-case dependent. This is an existing parking garage of about 750 spaces where they were replacing 175-watt metal halide existing fixtures with, and looking at the other technologies. The third column over from the left is the data on T8 3-lamp fluorescent fixtures. The next column over is if you take that same fixture and put a wireless controller on it. First column in from the right is 100-watt LED, and then 100-watt induction on the far right. At the very bottom, you can see the payback period is lowest with the fluorescent option. It also has the lowest first cost and lowest maintenance cost. Even though you're changing the bulbs more often, they're lower cost. But because of that, even though it has the lowest reduction in energy usage, it has the fastest payback. And these payback periods are without the utility rebates or tax incentives. So oftentimes the payback goes less than 2 years with these technologies. The last set of slides that I'll just click through are some advantages and disadvantages of the different lighting systems that hopefully if you get access to a copy of this presentation you can refer to later. Back to you, Paul.
Thank you both, Gary and Mike. So we had a couple questions about this payback period. In Mike's slides, he was talking about 6 to 10 year payback, 3 to 10 year, 3.5 to 5.5 year payback. Gary, your slide looked at a 10-year payback scenario, I think, and people are saying, they're having a hard time selling this internally because, as I said earlier, we're working on 3 to 5 year contracts. And partly it goes to this whole issue of sort of the mix of overall management here and the different viewpoints of building managers, building owners, and parking operators. Do either of you have any experience sort of working through these issues or suggestions, especially given how good fluorescent lighting looks as an alternative to LEDs?
Hey, we've seen more changing out of existing parking structures to new lighting technology by institutional owners, of a city, a hospital, a university. They're a long-term owner. If they can get the upfront costs approved in their budget, they obviously have the best incentive for doing this. In most cases, a building or a parking structure owner covers the lighting costs in our experience, not the parking operator. So they certainly, either one, I think, would have an incentive. I mean, in such a short payback period, it would seem silly for any owner other than trying to figure out how to cash flow it would make this change, and then you can finance it oftentimes through the lighting supplier.
Mike, anything to add to that?
Yeah, I mean, I think some of the experience we had was don't be afraid to monetize different things. And maintenance is by far one of the biggest, is more costly often than your actual electricity usage. So if you can, for instance, in the Regency, the Fairfax, Virginia site, they were paying a fair amount of money just for a maintenance company to drive around the parking lot on a pretty regular basis looking for outage. So, the LED technology in the parking lot is definitely much more reliant now than it was a handful of years ago, and manufacturers are getting more reputable. And so, with those two combined things, we know things are lasting longer. And so if you don't have to pay 1 or 2 electricians to bring out a bucket truck and to go out and replace stuff or just to monitor stuff, that's serious money. And that essentially that's how Walmart made their analysis. They factored how many times they're going to do relamping, and they said, oh, that's how they did it. The electricity was just an added bonus in terms of cost savings. The other one is think about what you're trying to do. The Carl Walker standard and our standard both focused on 2-foot candles minimum in parking structures. It's not uncommon for parking structures to be lighted to 8-foot candles or even 12-foot candles average. And the real question is, how much light do you need? More light does not mean better light. And so in terms of cost, if you can actually reevaluate how much light you're getting and where you're putting it, more uniform light is better than more light. Your eye actually adapts with the amount of light you have, and it does not like dark and bright spots near each other. That actually is harder for your eye to see. And so first is, how much light do you really need? If you're just trying to put a lot of light out, you're going to have some cost issues when you're looking at LED or certain technologies. But if you're trying to do a uniform layout, you can actually reduce your overall your expenses by just better lighting technology. So that would be the other thing I would say.
Great, thanks. Gary, we've had a couple questions about the slide that's currently up in the maintenance costs of $210,000 for LEDs. People are wondering what that's about.
The maintenance, it looks at lamp life and replacing lamps. It looks at fixture. For instance, you look up in the middle of that slide, there's lamp life, hours and years. And again, as I said, there's a lot of variables that go into this. In this particular example, the fixture we were looking at had a 50,000 hour life that they were using, which is 5.7 years if it's used 24/7, 365. And in this 10-year example of 10-year life cycle costs, the $210,000 did include replacing the fixtures at that 5.7 years.
Okay, somebody's raising that their experience has been that LEDs last more like 15 years, and that they're performing better than the 50,000 hours. Mike and Gary, what's been your experience with that?
Well, I would say that I guess it's a yes and no. There's no system that is out there right now that's using a traditional LED that we know right now that's been installed for 15 years. That would mean it's been installed since 1997. The best systems that we know of that are, what are using current technology, albeit an older architecture for the LED itself, have been really installed about 5 years at best. And if you think they've been operating, if they've been operating for 4,000 or 8,000 hours respectively, if it's a 24 operation, they're still only pushing 20 to 40,000 hours of operation. So why I'm saying that? The technology seems to be lasting a lot longer than we thought. We have new methodology that allows us to extrapolate with better accuracy or better predictive models, and it is not uncommon for manufacturers to claim life of 70,000 hours, 90,000 hours, or even greater, or some systems do even different systems. So LED life could easily be beyond 50,000 hours. That being said, there are definitely manufacturers who've come to lighting not from the lighting business, and they're maybe using the 50,000 hour value, but they don't have the reliability data to back it up. So I would say yes, it is possible, but just because somebody claims it does not mean I would believe it. They definitely should be able to answer basic questions of how they calculated it. It shouldn't just be a me too answer. If you're overdriving your LEDs, which is a way to reduce the cost, which just means to really push more current through them, so you're using fewer LEDs, but you're getting more light output, you're going to affect the life. But from certain manufacturers who really know what they're doing, 15 years, depending on your operating cycle, is a very believable answer.
Great. Gary, what's your experience been?
Well, our experience has been that it started out at 100,000 plus,
right,
3 or 4 years ago, and then there were some problems with installations, and then it was 80,000, and then there was the next round it was maybe 60 to 70,000. So it's kind of been on this downward trickle, and we'd like to see it turn back up. And I agree with, I think Mike gave a much better technical answer. I did just hear, though, at the Parking Industry Exhibition, the PI conference in Chicago in March, that there's some new standard that's out for calculating or actually going through a trial run to determine what the life of an LED is. And I just heard about it, but I'm not that familiar with it. Mike, are you familiar with that?
Yeah, and there's a couple of people asking kind of questions related to it. So in the question pane, I can see they're asking about LM80. So the way it works is that LM80 data is a measurement protocol for measuring the light output of just the LEDs themselves. And then you take data from an LM80 report and taking some information from an LM79 report, and an LM79 just is how you measure the light fixture itself. You can do, there's a new technical memorandum called TM21, and that lays out the math and how you calculate or project forward the life or the expected life of the LED system. The person who's asking this question about the LM80 data is the way it works is that the longer your LM80 data, you need at least 6,000 hours, but the longer, the better. It allows you to extrapolate more further out. So if you had 10,000 hours of LM80 data, you could extrapolate out to 50 or 80,000 hours with a better accuracy. And so in TM21 is still being somewhat revised, because I think there will be a new iteration sometime. I don't know when and exactly in the near future, but it is a mathematical model that they are definitely updating from time to time, because they get more data. Just as I said earlier, we have to constantly test these devices and then refine our models, just because they're changing at such a dramatic pace. But yeah, the projection methodology is called TM21.
So it sounds like doing some more research on this and looking at some of these tests might be something useful for us to look at moving forward. So we'll note that. Mike, there was an earlier question, I don't know if you can see it, if you can scroll up a little bit, about LEED and Cal Green requirements. Did you see that?
I did briefly. I'm not familiar with Cal Green. I'm guessing it's a State of California Green program. I am somewhat familiar with the LEED, depending on what metric we're referring to. They're asking about a .01 foot candle at 15 feet from the project boundary. They're asking both about the parking structure and the parking lot. I don't know where you would measure it in reference to the parking structure. I think it actually should be more related to the parking lot. When we developed the parking structure specification or parking lot specification, we did look at some different metrics, and I think LEED is changing somewhat on how they actually state where to do it. But there is lighting trespass terminology and values tells you where to measure it and where to calculate it at what height in the parking lot specification. And going back to the earlier question regarding the longevity of the LED system, both the parking lot and the parking structure specifications include language about what data manufacturers should provide and how the calculations should be done. Part of the reason why the specifications were developed was to prevent sites from having to reinvent the wheel every time, so include some of that language.
Thanks. Somebody raised a question about LED drivers failing and might need to be replaced in 5 years, and said some companies are now making components so you don't have to replace the whole unit. What do we know about that?
I think that's a great idea. I think for any of these fixtures, if you can replace a board of LEDs or replace the driver, I think that would make the maintenance cost less, hopefully, and the payback period less. We're starting to see that.
Yeah, I would agree. The power, just for some people who are not familiar, the driver is the power supply. It's like the ballast, or it's like the generator for induction lighting. They all have their own separate life ratings, independent of the actual LEDs themselves, or in this case, drivers have them independent of the LEDs themselves. It is definitely, I think, in terms of what's going to fail, the LEDs will last longer than almost everything else in the fixture. So it's in terms of where your failure points are, your driver is probably going to fail before your LED system, and so it probably makes sense to include some aspect of future maintenance. Whether it's 5 years, you really need to look at some of the reliability specifications of the driver, which they have different metrics that you could consider.
Okay, Mike, has the DOE been working with manufacturers on some of these issues and what the possibilities might be for the future?
Yeah, the Department of Energy has a very active solid-state lighting program. You saw some of those slides. They also support a number of different industry organizations. So the Department of Energy helps support. They did not write. They just helped provide technical data and other things for such as TM21. I believe they're doing something with a driver specification. I don't know the exact status of it, but again, these are not coming from DOE. They're just really helping support the industry, whether it be through technical information, resources, whatever they can be. One of those other things is called NGLIA, which is the Next Generation Lighting Industry Alliance. They're really on the forefront for LED reliability. So they come out with different documents and even newer metrics. Some people on the phone might be familiar with a term called L70. That's which refers to 70% of initial light output. And it's the way most people right now define end of life of an LED system. NGLIA now has a new document out that they're really championing, which is saying, well, you should really be looking at other metrics. L70 may not be the value you want. It kind of walks you through what other values you should look at, but you should also not just look at light depreciation, but look at actual failure, and there's different types of failure, and so yeah, the Department of Energy is really trying to. I think the thing that DOE learned was that CFLs, while they're great, they kind of were set back early on because either there was some misnomer about it, that people were pushing them when they weren't for the best applications, and they're trying to say, well, wait a minute, we've learned from CFLs. We're trying to, we're trying to help come up with standards so that people can figure stuff out earlier rather than being burned by the technology and being delayed like we saw with CFLs.
Thanks. The final question, unless anybody weighs in with anything else, is about how important have local and federal incentives been from utilities and the government for making the decision about which energy efficient lighting upgrades people have been choosing. Has that been significant in their decision-making process? Gary, Mike?
Well, I think a lot of our clients that have made these sort of improvements are nonprofits, the hospitals and universities and cities that don't get the tax advantages. They do get some utility rebates and, of course, the reduction in their energy bill. But for private owners that are for profit, certainly it makes a difference. And I didn't point out on one of my slides there is a list of a website that I'm coming to it here in a moment that lists all of the rebates available to utility companies across the country. And here it is, right below the green word rebate is the website is dsirUSA.org. If you go to there, you can find the utility company rebates, but they make quite a difference if you can get state tax credits or deductions through EPA Act, the federal program, or utility rebates. It can certainly shorten the payback period and reduce your costs.
I would follow up with that. I think the EPACT is a great tax incentive program. Another one is the Design Lights Consortium. Desire really provides rebates across different technologies, and even when it is lighting, you sometimes have to dig down for it. The Design Lights Consortium is managed by utilities, and it actually includes a qualified product list. They set basic standards such as how much light output and efficacy and some color and some other reliability issues. When the parking structure specification and parking lot specifications were born, we specifically tried to partner or marry or not really marry, but build around the Design Lights Consortium specification or Energy Star. So rather than coming out with another fixture-based specification, the idea was that those are fixture-based, and you could use them to meet the performance-based specification. And Design Lights Consortium, I think it's dlc.org, but if you type in Design Lights Consortium, you can find it. It provides an Excel-based database right now, and you can find qualified products right now. There's a number of utilities that support it and that incentivize directly for it. They have a fair amount of outdoor lighting and parking lot and parking structure available on it, and I think it's a great resource but it only applies to LED lighting. So if you're looking for fluorescent or induction for parking structure, you'll have to kind of go the traditional route.
Great, thank you. We will post the Design Light Consortium information on our website. Now Trevor's going to wrap us up.
I would like to thank our expert presenters for taking time out of their day to educate us on this topic. The knowledge they have shared will help to catalyze our industry's transition to energy-efficient lighting. As of tomorrow morning, this presentation, as well as our panelists' contact information, will be available on the Green Parking Council website. I encourage you to reach out to Paul, Michael, or Gary with any questions that were not answered today. We ask that you participate in the survey, which will be available after this presentation concludes. In addition, please email me with any suggestions you have for future webinars at trevor@greenparkingcouncil.org. Thanks for joining us.